Okay, today we're going to be talking about the square root property, and here are the examples that we're going to be talking about in this particular video, in order. Now, the book calls this section quadratic equations, and the reason why is because the square root property has to do with quadratic equations, but the square root property is the only part of 9.1 that we're going to talk about. So I'm just calling it the square root property. Now, the square root property applies when, and this is kind of theory, applies. Let's go down a little bit. The square root property applies when you have a quadratic form. Remember, whenever you have a quadratic form, ax squared plus bx plus c equals 0. I'm too low. Okay. So this is a quadratic. This is a quadratic equation. So there are cases where this b here is equal to 0. So that means this whole term disappears. Because if b is 0, then 0 times x is 0. And the only thing you'll have left is ax squared plus c. And the square root property can help us solve equations of this type. Now, let's go ahead and go down. That's just some theory behind it, but let's go into this concept. So let's talk about two different numbers. I think I may have scrolled down too much. Yeah, okay. So we have two different numbers. -2 and 2. -2 and +2. Let's square both of these. So -2 squared. Okay, -2 squared is equal to 4. Because you have a negative times a negative equals a positive. So it's -2 squared equals 4. And also, +2 squared equals 4. So these are two different numbers that when you square them will both give you 4. So now let's look at an equation that we need to solve. Now let's look at x squared equals 4. Period. Okay, period. So now let's look at x squared equals 4. Now we want to find as many solutions to this as we can. And we can see from here, if we put in -2, it solves it. If we put in +2, it solves it. So that means there are two different solutions. So there are two different solutions. -2 and +2. So so we can see that there are each of these numbers. I'm going to go ahead and put a parentheses around this too, just so for the sake of standard, so it looks more like it makes more sense. So if we want to solve this algebraically, we need to take this into consideration, that there are two numbers that when you square them will equal 4. So solving this algebraically, take the square root of both sides. Oh, line break. Okay, so now let's go ahead and scroll down a little bit. So we have x squared equals 4. I'm just rewriting the equation. Oops, x squared equals 4. And so what we have now is x equals square root of 4. Oh. Why is it? Okay. Or x equals the negative square root of 4. Okay, so x equals the square root of 4 or x equals negative square root of 4. See, our intuition might be just to take the square root of both sides, which will give us just this equation, which will give us only this solution. But there are two solutions, so we need to have this equation as well, and that will give us this solution. So we need both of these individual parts to find all the solutions, and that's important enough that I'm going to write that down. We need both of these parts to find all solutions. Okay, so there's a basic rule of thumb whenever you're solving these types of algebraic problem. And I'm going to write this problem down a little bit more formally a little later on. So, oops, I didn't mean to scroll down. So, but I guess I probably will anyway, because now we're going to the rule of thumb. Okay, so the rule of thumb is that if a problem starts out with a square root, oh crud, line break. If a problem starts out with a square root, it means it means just one positive square root. And we've seen that before. We've seen a lot of problems that involve square root of 4 or something else. Like in section 8.5, we had the square root of x plus 4. But on the other hand, however, if you put the square root into the equation, then you separate the problem into two equations. I think that's probably going to go on to the next line. Okay, so let's go ahead and go through this again. If a problem starts out with a square root, and I'm going to write an example of that down below here. So if we have square root of x plus 4 equals I don't know, 36. So, wow, that's a big number. I just realized that, well, it doesn't matter. So square root of x plus 4 equals 36. This is an equation that we start out with a square root because we're given the square root. So that means this means just one positive square root. So let's change that 36. I'm changing the problem from 36 to 6 because I didn't mean to make it so big. So this would be an example where we would square both sides, and we'd get x plus 4 equals 36, and then we'd get x equals 32. And that was from section 8.5, I believe. But if you put the square root into the equation yourself, and let's have an example of that. So let's say if we have, we already had one example, but let's go ahead and let's look at that example again. So we have x squared equals 4. Okay, this is an example where we don't actually have a square root, we only have a square. But to solve it, we're going to need to take the square root of both sides. So that means we're going to have to separate this into x equals square root of 4, or x, that's s, x equals square root, negative square root of 4. So, if you put the square root into the equation yourself, then you separate the problem into two equations. And here, in this particular case, are the two equations. So, let's go on to another example of the same type of thing. Okay, so example, x squared equals 36. So just like before, we want to take the square root of both sides, but to do that, we're going to have to separate this into two different problems. So we have that x equals square root of 36, or x equals negative square root of 36. Oh, I thought I put a negative there. Negative square root of 36. Notice something important though. The negative is outside the square root. This would be different from the square root of negative 36. This means something completely different from this. The negative, for what we're doing here, the negative will always go on the outside of the root. This will give you what's called an imaginary number, and you'll probably talk about that in the next algebra class, but as far as I know, you won't in this one. They do talk about it in the book, though. So we have that x equals square root of 36, or x equals negative square root of 36. So the square root of 36 is going to be 6. So we have x equals 6, or x equals negative 6. Because we get x equals 6 from x equals 36. We get x equals 6 from x equals the square root of 36, and we get x equals negative 6 from x equals negative square root of 36. Now, there's also another way to write this, and I want to go ahead and put this down here, not because it's necessary to do it this way, but because you're going to see it this way. You're going to see this in the book, you're going to see this in future algebra classes, you're going to see it a lot. So let's start the problem from the beginning. So we have x squared equals 36. Now we can write this as x equals plus or minus the square root of 36. Now notice something. This plus or minus, this technically means it's two equations. In fact, this, oops, I didn't mean to accidentally cross it out. This means the exact same thing as these two put together. But they mathematicians often write it this way because it's faster. However, to do this, there are times when that might be problematic if you don't understand exactly what this means. All this means is that you have two different equations. So that means that you can also write this. So to complete this problem, you can write this as x equals plus or minus 6. And notice that this means the exact same thing as this. X equals positive 6 or x equals negative 6. So now I want to go into a formal, more or less, statement of what the square root property is. The square root property. The square root property says that if a squared equals b, then a equals square root of b, or a equals negative square root of b. Oh, I forgot the negative again. Whenever you're typing it out, it's easy to forget that. But remember, this is the first way. There's two ways to state this. So this is the first way to state it. So I'm going to do both ways. the other way of saying this is if a squared equals b, then a equals plus or minus square root of b. So again, notice that this a equals plus or minus the square root of b means the same thing as this. This is just another way of writing it. Sometimes this can get to be kind of confusing, this terminology, but as long as you understand exactly what it means, that we have two different equations, then it's easy to get past any confusion. So let's go on to another example. Okay, so example. If we have 4x squared minus 68 equals 0. Oops, that's not 68, that's 69. So 4x squared minus 68 equals 0. Okay, so notice first of all that we want to get this in a form that we can use the square root property, but it's not there yet. We don't have a square on the left side of the equation, or it could also be on the right side, but as long as it's alone. So we need to have the squared term alone. So we can write this as we can rewrite this as, I'm going to go ahead and put a separation just so you can see that this is a new section. So let's go ahead and add 68 to both sides of the equation. So you get 4x squared equals 68. Okay, so now we have the squared term over here. Now, since 4 is a square, you can go ahead and take the square root of both sides now. But I want to go ahead and get rid of that 4 because I want to get just x squared by itself. So we have x squared equals 17. Okay, so yeah, that makes sense. So x squared equals 17. And I want to go through this again. We couldn't use the square root property yet because we want a square term to be alone before we can do it. See, in the square root property we have a squared. It's not a squared plus c, it's not a squared plus b, it's just a squared. So this is not an a squared term. On the other hand, this down here is an a squared term. So I want to get the x squared by itself. So now we have x squared equals 17. So now I'm going to use the second formulation, the second what's what I'm looking for, the second form, more or less, just because we're going to see that occasionally, so I want to go ahead and use it. So we have that x equals plus or minus square root of 17. Oh, I need to scroll down a little bit. So x equals plus or minus the square root of 17. Okay, so now let's go on to one that has something slightly more complicated. Oh, and this is going to be our final answers. I mean, I should say this is technically two answers, remember, because it's positive 17 and it's negative 17. Okay, so let's go on to a slightly more complicated example. So we have x plus 2 squared equals 18. Okay, so x plus 2 squared equals 18. Okay, notice that this is already in the form of a squared equals b, but also a is going to be x plus 2. It's not going to just be x because we have this entire thing squared equals 18. So we want to take the square root of both sides. So let's rewrite this as x plus 2 equals plus or minus square root of 18. And if this plus or minus does confuse you, you can just feel free to write this as two separate equations. X plus 2 equals square root of 18, or x plus 2 equals negative square root of 18. And if you do that, work through it, and you'll see that you're getting the exact same answers that I am. Okay, so x plus 2 equals plus or minus the square root of 18. But we're not solving for x plus 2, we're solving just for x. So we want to get x by itself. To do that, we now need to subtract 2 from both sides. Now, whenever we have a plus or minus and we want to subtract or add something from it, what we usually do is we put this in front of the plus or minus. So that means we'll rewrite this as x equals negative 2 plus or minus square root of 18. And I don't know exactly why we do that, probably just to avoid confusion. But whenever we have a plus or minus, you want the plus or minus to be the last term that we have over there. So we're still not quite done yet though, because, well, what's 18? Okay, I'm going to try this. Hopefully it won't look too bad. So we have 18. Well, that's equal to 2 times 9, and that's equal to 2 times 3 times 3. So that means the square root of 18 is equal to square root of 2 times 3 times 3. I may be out of my league trying to write all this way, so that means we can cross out 2 3's, a pair of 3's, and put it out front, so it's equal to 3 root 2. So we can simplify this right here as x equals negative 2 plus or minus 3 square root of 2. Okay, so this is going to be our final answer, but again, it's two different answers because of this plus or minus. Now let's go ahead and go on to another example, and this one is going to also be a little bit different. Okay, so this one, let's go ahead and go over it again just briefly. We have that x plus 2 equals plus or minus root 18, and then we move this 2 to the right side, and whenever we move a term to a side that has a plus or minus, you always put that on the left side, just to avoid confusion later on, I think. So then we have x equals negative 2 plus or minus root 18. Well, we can simplify this root 18 to 3 root 2. Okay, so now let's go on to one more example. Example x minus 6. Oops, forgot to go into math mode. Okay, so x minus 6 quantity squared equals 25. Okay, so I'm going to do this two different ways. One with each form of the square root property. Remember, square root property, first I'm going to do it this way, this top way, then I'm going to do it the bottom way. So for the top way, okay, first way. And again, I'm actually solving the same problem. I'm even doing it the same way. I'm just visualizing it differently. So we have x plus minus 6 quantity squared equals 25. So that means this will break into two different equations. We'll get that x minus 6 equals 5, or x minus 6 equals negative 5. So x minus 6 equals 5, or x minus 6 equals negative 5. Okay, so that might be a little bit confusing. Never mind, sorry. Okay, so now we have two different equations, so we can solve each of these equations individually. So we have that x minus 6 equals 5, so we can add 6 to both sides, so we'll get that x equals 11, or, and then we have x minus 6 equals negative 5, so we can add 6 to both sides, and we'll get x equals 1. Now we can go ahead and check these if we want, and that'd be good practice. Right now we're not going to do it, but if you're on a test and you want to be sure of your answer, then you want to go ahead and plug this in. So, well, you know what? It's not going to be that. I'm not going to type it out, but 11 minus 6 will give you 5. 5 squared will give you 25. And 1 minus 6 will give you negative 5. Negative 5 squared will give you 25. So this was the first way to do these to do this, the first square root property. Now I'm going to do it the other way. So second way. So we have x minus 6 squared equals 25, and x minus 6 equals plus or minus 5. So remember the second way, we use this concept right here. Since x minus 6 squared equals 25, then x minus 6 equals plus or minus 5. Let's scroll back down. Oh no, we want to get as much of this as we can. So that means that we can go ahead and add 6 to both sides. Remember, we're going to put it on the left side of the plus or minus. So that means x equals 6 plus or minus 5. Okay, so notice something. You might otherwise be tempted to leave it like this. And the reason why you might be tempted to is because, like for this example right here, we did leave it with a plus or minus. But the reason why is because there's no way to simplify these. If we separate this into two equations, there's no way to simplify this any further. But in this case, we have 6 plus 5, or 6 minus 5. So that means we can say this is x equals 11, or x equals 1. Because we have the 11 is from 6 plus 5, and the 1 is from 6 minus 5. So you don't want to leave your answer this way, because you can simplify it a little bit further. Okay, so let's go back up again. Why did we not simplify this? Why did we leave it with a plus or minus here? The reason why is because if you separate these into two different equations, and I'm going to go ahead and do that. So we have x equals negative 2 plus 3 square root of 2. X equals negative 2 plus 3 square root of 2. Or x equals negative 2 minus 3 square root of 2. Oh, whoops. Oh, crud. I had a typo in the code. Okay, so we could separate this. So this is the same thing. It means exactly the same thing as this right here. But can we simplify this any further? Negative 2 plus 3 square root of 2. Well, no, you can't combine these two terms. Can you combine these two terms? No. Negative 2 minus 3 root 2. So since you can't combine these and you can't combine these, this is as far as they simplify. However, you can just, the only thing that they differ by is the sign. This is plus, this is minus. That's why we can just leave it in this form. That might sound a little confusing at first, but if you think about it for a little while, think of it. In fact, if you want to, if it's confusing so much, if it's confusing to a point where you have a really hard time understanding it, there's absolutely nothing wrong with writing it out this way every single time. You're going to see it this way in other classes. You're going to see it that way in the books. You're going to see it in examples. You're even going to see it in my examples. I mean, like this one here. But if while you're solving it you have a hard time understanding when do I separate this and when do I don't, then you can separate it every time. And there's absolutely nothing wrong with that because they mean exactly the same thing. Okay, so now we have one more example, one that kind of combines everything. So let's go ahead and get to it. Example. So we have 5x minus 2 quantity squared minus 16 equals 9. Now I chose these numbers for a reason. You might be tempted to think, oh, well this is a square, this is a square, and this is a square, so I can just take the square root of all three of these parts. But you can't, because to take the square root you need to have a square and a square. Well, this doesn't technically need to be a square on this side. It just needs to have, this term needs to equal something. This has to be, remember, this is your a. In the form, here, go ahead and write it. When you have a squared equals b, then a equals the square plus or minus the square root of b. Okay, so this term right here is the only one that has a square. So this is your a. So that means you need to get this into this form. This whole equation needs to be put into this form. So you need to go ahead and add 16 to both sides. Okay, now I'm going to get rid of that now. You don't need to write that down. That last part down. I just did that to show you the square root property again. So we need to add 16 to both sides. So that means we'll have 5x minus 2 quantity squared equals, now 16 plus 9 equals, oops, not 5, 25. I forgot to put the 2. Okay, so 5x minus 2 quantity squared equals 25. Now we can apply the square root property. So we can say that 5x minus 2 is equal to plus or minus 5. So we have two equations. 5x plus 2 equals positive 5, and 5x minus 2 equals negative 5. So that means, for now I'm going to go ahead and keep it with the plus or minus sign. So we'll have 5x equals 2 plus or minus 5. And then we can divide, so I just added 2 to both sides, and the 2 goes on the left side of the plus or minus. And now we can divide every individual piece by 5. Now that might sound strange at first, but you can go ahead and divide. Think of it this way. If this right here were a plus, you could divide every individual piece by 5. If this were a minus, you can divide every individual piece by 5. So that means, since this is a plus or minus, you can divide every single individual piece by 5. that may have made it sound more confusing than it really is. But the bottom line is you have a 5x equals something, so you can divide that something by 5. So we'll have x equals, I'm going to go ahead and write it as a fraction, 2 plus or minus 5 over 5. So x equals 2 plus or minus 5 all over 5. Now this can be separated into two different fractions that have the same denominator. 2 fifths plus or minus 5 fifths, and then 5 fifths is going to be 1, so this will be 2 fifths plus or minus 1. Okay, so we're not quite done yet though, because we have a rational number plus or minus a rational number. We need to go ahead and separate that out. Okay, so that means we have x equals, and we're going to have 2 fifths plus 1. Well, 2 fifths plus 1, 2 fifths plus, I don't know why I did this on a slant. I'm going to stop the slant. It's going to go normal. 2 fifths plus 1 is going to be the same thing as 2 fifths plus 5 fifths, and that's going to equal 7 fifths. So x equals, x equals 7 fifths, or this is just the plus part, to 2 fifths plus 1, or 2 fifths minus 1, so you have 2 over 5 minus 5 fifths. I'm still hoping that one day my mouse writing will get better. Equals, okay, so we have like denominators now, so we can go ahead and subtract them. 2 minus 5 will give you negative 3 fifths. So x equals 7 fifths, or x equals, oops, I forgot to, x equals negative 3 fifths. Okay, so that means that these are as simplified as they go, so these are our individual answers. X equals 7 fifths, or x equals negative 3 fifths. And that concludes section 9.1. It looks like the next section is going to be 9.2, but then we'll be skipping 9.3 and going into 9.4. Alright, I'll see you in the next video.